So I'm going to give you an example of an application of IIoT at Duke Energy for predictive maintenance. Give you a little bit about Duke Energy. At a glance, it's the largest electric power holding company in the U.S. We've got regulated utilities in 6 states, about 50 gigawatts of power. Renewable energy across the U.S. is 2,500 megawatts. International energy at South America, about 5,000 megawatts. I'm responsible for the equipment reliability and technologies across the fossil hydro fleet, which is about 42 gigawatts of that power. So we got 92 plant sites, 324 units, so just a large amount of units and plants, and the challenge of different cultures and 5 legacy companies and how we roll out equipment reliability across the fleet. We also have 4 monitoring stations, one up here in Indianapolis. We have Charlotte and Raleigh, and then we also have a monitoring center down here in St. Pete that monitors the health of the fleet. So why SmartGen, IIoT for power plants? A lot of good reasons. You know, a lot have been talked about this week, but for us, it's avoiding major catastrophic failures. Back in 2010 here in Florida, we had a transformer explosion, actually took out 3 other transformers, actually took out the buses, we lost DC power, we wrecked 2 turbines, tens of millions of dollars worth of failure and months of lost generation power. I just told you I'm the guy responsible for equipment reliability, right? So guess where I ended up? Top floor talking to the executives. How did we miss this? What went wrong? So we did a lot of looking and seeing. I think probably pretty standard in the power industry is a lot of manual data collection for health. We do manual programs implemented in the 90s. We do handheld vibration. We do handheld oil analysis periodically. So not a lot of automated monitoring. So what we saw was the gap was really we didn't see the online sensors and diagnostics on our critical machines. We couldn't tell continuously. This particular failure, actually we knew that transformer had some issues, but we thought it had life left. And we review the health of these things every 6 months. So between those 6 months, we had a couple of bus issues that pushed the transformer over the edge. So we needed that online continuous monitoring. Also data management and integration. 5 legacy companies, health information and file cabinets all over the place. You know, so how do we integrate and truly understand the health of machines and pull it together and really visualize the health, you know, and understand the risk of our critical components with some of the gaps that we found. Again, it's 2010. So that challenge was how do we better leverage technology to address increasing reliability issues. We wanted it both for reliability and for operations and actually optimizing our workforce. So our approach to this, and we really didn't know in 2010, we really didn't know anything about IIoT. We're living in our power world. But what we did see is we needed a monitoring and diagnostic infrastructure. There are control networks in the plant, there are business networks. Our concept was to put an M&D infrastructure in, both wired and wireless, where we can plug and place sensors where we needed it across the plant. We wanted to do a significant advancement in remote equipment monitoring. We needed smarter in diagnostics and prognostics. We need the technology to tell us what's wrong. We don't need humans looking at every little thing that comes in. Data integration and visualization we just talked about. And we also wanted to enhance a reliability process where everybody across our fleet was using the same process. They understand how to get information. They understand their role and understand in assessing equipment health. And we also looked at zero event operations. Those safety environmental issues. Some of you may have seen Duke Energy on 60 Minutes where we talked about our ash pond leak. Very embarrassing to the company. So big effort in putting sensors on ash ponds and anywhere we could get any type of release into the rivers. So major investment there. You really wanted to provide a fleet force multiplier where we could leverage a few specialists to do the remote monitoring across our fleet. I had 3 combustion turbine experts, centerline combustion turbine experts for 350 turbines all over the East Coast. We had to use technology. We want to shape our future with technology innovation and workforce optimization. So a little bit of the IIoT speak, so what we wanted was smart plant connected assets. We identified our critical assets. We identified the sensors, the analytics, the failure modes on those assets, and what do we need to do to actually interact with those assets and actually compute the health, and how do we connect the other information and also connect to the right people, which gets us to integration of people, processes, assets, and data equals the better decision making. One of the things we did also was to build a model of each of our types of plants. You probably saw we have coal, combined cycle, combustion turbines, hydro, pump storage. We got about one of everything, a lot of wind and solar. So we wanted to look at each generation asset type and identify what sensors needed to be added. Again, plants are usually built with really good controls and basic monitoring. We wanted to take it to the next level for advanced sensors. So we looked at all the different types, looked at the assets. We looked at failure modes and effects analysis. Most of the FMEA, and we work a lot with EPRI, which is Electric Power Research Institute. They built FMEAs and failure signatures. We wanted to say today, most of these were built 10, 20, 30 years ago. If we pull the cover back on, and there are failure modes we don't have a failure signature for now, or an indicator with new sensor types, with new analytics, could we develop that? And could we add it? So that was a key. So what have we done? We looked at 10,000 assets across 50 of our critical plants. We looked at the sensors that we just talked about. We set it in 3 phases. First phase were the usual things: vibration, advanced diagnostics on our turbines, oil analysis, cameras for visual, low-hanging fruit that we knew we could get things right away. We've also moved into advanced sensors, a lot of IR, EMI, motor current signature analysis, a lot of extra things we could do to address major components. And then the piece on further advanced sensors was around zero event operations, safety, environmental, what could we do to prevent major events from happening to the company. We put an infrastructure in the plant, 2,000 nodes. We selected the National Instruments Compact Rio. It had over 100 different modules you can plug and play for different sensor types. And we built a monitoring analytical system called Insight CM that we could do the analysis remotely. We also built the Monitoring and Diagnostics Center, which had been around since actually 2007. We use Schneider Electric's Advantis Prism APR. We've grown with adding the sensors from 3,000 to 10,000 models, and we like to think they're smarter models because we're using those sensors coming in. And I'll show you the results here in just a moment. We're also playing with some big data analytics with some other vendors. I think that cognitive learning is a key direction to go. We're also working with Schneider on some concepts there. And again, this whole data integration and visualization. With thousands of assets across our fleet, how do we quickly understand and drill down to the thing we need to look at? So all of this infrastructure is to say, of the thousands of assets, here are the top 10, 20 things you need to look at right now, and how do you visualize it? And how do you compare that against assets across your fleet? So again, this is major focus areas now is in the advanced sensors and these technologies to continue growing. A little bit of a model to show you how it works. So again, controls network, all the things that were coming out of DCS going to the historian and end up in our M&D center with the Prism modeling tool. All the new sensors that we built in this new M&D network that ends up in the historian, adding more new capabilities. The manual still flows into, we use a product called PlantView, which is a kind of an asset health management system, where all the manual, the online, the inspection information ends up in PlantView. So this is kind of the model. So this feeds out of the M&D center here. Our plant CBM, our SMEs, our system owners look at all the information coming in around the different pieces of equipment and make an overall assessment of the health. Someone was talking this morning about data models and how do you build this infrastructure. So we went from a get data problem, and we got a lot of data. We got a got data problem now. We've got 300,000 PowerPoints pulling in. We got machines active with sensors, and just this whole infrastructure. So IT has been very involved with our project on how to layer this data. We're pulling terabytes of information. If you think about waveform information, vibration waveforms are being handled all the time across 6 states. So that whole infrastructure has to be carefully built so you can understand this information. So you take lots of information that comes in, and the output, again, is these 10 things you need to look at and get you to that point. One example of a find is one of our turbines. This was last year. So we pick up small changes in vibration in the M&D center, and the concept is we see it long before the operations folks see it. So the vibration may be up at 5 mils. This is a small wiggle of data, and we look for those small changes, and that's what the PRISM software does. It patterns what normal behavior is and tells you when small changes happen. So our center picked this up. We notified the engineers in the plant. We'll let them know that something didn't look right. And what we're looking at here is subsynchronous information, something we've never seen before if we hadn't put the advanced sensors and advanced diagnostics on a turbine, because just overall vibration wouldn't have moved. So this is real key to us. So this is a flow sleeve, directs the steam flow in the turbine, inside of the turbine. Bolts had come loose, and the edge of this thing had nicked the blades. So turbines just got rows and rows of blades. So did a little bit of damage, and we saw that wiggle, and that's when we shut this turbine down. If we had waited, this would have liberated. This is actually picture taken off. It would have wrecked this turbine. We put an estimated avoid cost at $4 million. This is a $20 million failure. It would have corn-cobbed that turbine, would have took it totally out. We've had 3 of these just in the last 6 months. So that's the power of new sensors, new data, smarter analytics. Yeah, so since we've installed all the sensors, a little bit of an eye chart for you, but this is notifications. This is the last 3 years. This is how the notifications have increased based on all the new sensors, all the new models we built. Fines have increased to 384, and we're up to 31 million. And we only do the calculations on key fines. Not all 384 were calculated. And again, very conservative. So I think this number is much higher than that. So we're showing our executives the value is in investing in these new technologies. The payback is there. It's not a 20-year payback, and it could be one turbine fine that pays for the whole system. So the value is there. Another eye chart for you. This chart is really around connectiveness and understanding. And we have relative cost of the project. So here's all the investment we've made with the infrastructure across our plants on cost. And in the center here, the linear line is data to information to insight and actionable intelligence. So we feel we're probably somewhere in here. We made the investment in the infrastructure, and now the value of this is just going to increase as we add smarter analytics, as we integrate data. It's going to get us up to this actionable intelligence area. So this is like Ralph's chart, value and difficulty, and really taking it from diagnostics to predictive to prescriptive analysis. And it's the holy grail if a plant manager can call you and you can say, your turbine is going to fail 3 weeks from Friday. That's a pipe dream for most of us. But usually we see something change, and it's really hard to say when it's going to fail. But I think as this cognitive machine learning and those type of technologies become more available, we'll be able to climb this value chain and really get to that point. I think that's the future for us. Been doing this for 35 years. That's been the holy grail. I think we're getting close to being able to do this. So where's Duke? We talked about. We built the network, the infrastructure. We've handled the cyber security issues. We've handled all the IT issues around how we handle data. So that first one was a huge accomplishment. We put the main usual sensors in. We really extended that ability to do remote monitoring from our SMEs across our fleet. And we're continuing down this trail, and I think the sensors are going to continue for a really long time. just in the 5 years, it's amazing to see where sensor development is. And I think you probably all see this, you know, in the work that you're doing. They can custom design a sensor. If you can identify the failure mode and what sensor you need, it's out there. You can build it. And just the increasing efforts in the advanced analytics, you know, like I said, the data integration and visualization. So to me, here are the technology enablers. You know, it's more wireless. You know, it's, even for power plants, it's like, some IT groups, it's hard to even accept the fact that we'll put wireless in because that's a security issue. But I think we're getting over that as an industry now. I've heard a lot of talk this morning, even in the talk session with the executives, the open enterprise. It's so key to us, and one reason we picked one of the vendors we did is because they're open. And that whole thing of being siloed and you got to buy my whole solution, right, is over now. You know, I think most vendors realize we got to open and we got to exchange information. So key to us. Advanced sensors, wireless sensors we talked about. So we talked about all these things. So to me, it's the second wave I've been involved in. I chose to stay in the equipment reliability space my whole career. So back in the 90s, late 90s, mid 90s, we rolled out predictive maintenance programs. You know, we had the handheld vibration monitors, the big thermography cameras that were $60,000, $80,000 a piece, and we rolled that out. And that's been a very effective program. And we started that, and everybody said, we don't have the resources, we don't have the people, we don't have the money to invest in it. You can't find a plant anywhere that doesn't have that now. I'd say in 5 years, this is the next wave of equipment monitoring for power plants. EPRI now calls this, we called it Smart Gen. There was Smart Grid, it became Intelligent Grid. Actually now, so they couldn't call it Smart Gen, so it's I4 Gen, it's intelligence for generation. So that's the IIoT movement in the power industry now. Okay.